I'd like to invite JF to join me on the stage when you're ready. He's the founder of MAASS, and he's been in the industry for a number of years, so good luck.
Thanks. All right. Can you hear me? All good? Okay. Well, thank you for coming here. I see a lot of really smart people, but I also see survivors here. It's been a long conference, so good on you. Pat on the back for that. I saw a lot of really good presentations as well. I really want to give my hand to all the people that have presented. People have provided a lot of food for thought for myself. Unfortunately, I couldn't change my presentation and add other qualifications. But going on, let me talk about what we're doing here at MAASS. So my name is JF. I'm founder of MAASS. I'm also part of an R&D lab called Nectar, my partner Nick. And just a little bit about myself before I get into our path to multi-material fabrication. So I've been working in 3D printing for about 15 years. I've been working with inkjet systems, both large and small, hardware and software. An image here is actually when I was working with D-Shape, I was printing with a 3-meter swath inkjet system where each nozzle was about the size of a quarter to print concrete. The idea was trying to build buildings, which I always assumed were like big prototypes and perfect use for 3D printing. I also worked with a lot of other companies. I worked with GrabCAD, which is a Boston company, which had 1.5 million engineers on a sort of social site with a large CAD library for 3D printing. I worked in 3D Industries, a company that did Google 3D image search. So you load SDL, find similar SDLs. I also developed some materials, for example, a material that could, if you soak a PLA print, it will turn into like an elastomer. The idea being it's hard to print flexible print materials. This is like 10 years ago. So let's come up with a post-processing process. So these are the kind of things I've been working on for a very long time. And of course, I also worked with Bod Factory for a period where we printed electronics. In sort of my career, I noticed quite a lot of things that weren't being addressed in 3D printing. And these two images, let me explain what they mean. So one image here is a materials chart. I'm sure you've seen these before. And another image here is an exploded view of a hearing aid. The hearing aid actually has one 3D printed element used. And it's probably the most popular use of 3D printing in terms of units. The ear canal is often different for each person, so that part is often 3D printed. Everything else within the hearing aid is, of course, not printed. But a lot of the materials you see in that material chart are used in hearing aids. And so one of the issues I've sort of kept on seeing in 3D printing, and I'm sure you have too, is where a lot of technologies out there are very siloed. It's very easy to print with one specific type of material, one area of material, and mixing them in discrete manner would allow us to print, for example, something like all the elements of something like a hearing aid and reduce the costs involved with assembly of something like a hearing aid and the other elements like that, and may potentially allow for form factors that would not be possible with existing processes. So I started with essentially what would be the characteristics of an ideal multi-material AM technology. And I kind of coalesced around 5 basic concepts. I think the ideal sort of multi-material AM technology would be scalable. It has to be a technology that you can take in the lab and put it into the field relatively easily. It's scalable in that respect. It's also scalable in a volume size, where, for example, if it's 2 to 3 times bigger in volume, it's going to be able to print more and there's no other issues. You're not going to see warping and other issues. I was sort of coalesced on, I felt like the ideal technology would have a voxel size of around 50 microns resolution that is. I think an ideal multi-material printing technology would have something like embedded parts, elements that you can put inside a print. I think this is super critical and I think it's forgotten sometimes. And I think the 2 other things that really matter to, let's say conceptually the perfect multi-material fabrication technology would be able to print metals and plastics that have a high degree of density. So there's, uniformity in the material as well as purity. So it's specifically one type of material and not another. And an AM process, my goal is to sort of look for an AM process that has a wide variety of material receptibility. When I say receptibility, I essentially mean you can take materials off the shelf and use it in this AM process.